Welcome back to the Aptos developer course. Today we are building something really exciting. We're going to build our very own fungible asset, or in simpler terms, a custom token on the Aptos blockchain. Now you might be wondering, why should I care about creating a custom token? Well, let me tell you, custom tokens are the backbone of many blockchain applications. They can represent anything from in-game currencies to real-world assets, loyalty points, or even voting rights in a decentralized autonomous organization. Possibilities are endless. In this video, we're going to create a fungible asset that's more than just a simple token. We'll be implementing features like minting, transferring, and burning tokens. But we won't stop there. We'll also add some advanced features like access control and event emission. By the end of this video, you'll have a robust production-ready token system that you can adapt for your own projects. Before we get into the code, let's quickly set up our development environment. If you've been following along with our series, you should already have the Aptos CLI installed. If not, please go ahead and check out the video 1 of this course. Once you have the Aptos CLI ready, let's create a new Aptos project. So open your terminal and run this command. This command creates a new Aptos project structure for us. You'll see a new directory called My Fungible Asset with some files and folders inside. The most important ones for us are the sources directory, where we'll put our move code, and the move.toml file, which is our project's configuration file. Let's talk about designing our token structure. When creating a fungible asset, there are several properties we need to consider. These include the token's name, symbol, total supply, and decimal places. Each of these properties play a crucial role in defining how our token behaves and how it's perceived by users. In our case, we're going to create a token with the following properties. The name will be my fungible asset, symbol will be MFA, decimals 8. Total supply, we'll make this dynamic, allowing new tokens to be minted as needed. We're also going to add a couple of URLs, one for the token's icon, another for its website. These aren't strictly necessary, but they add a nice touch of professionalism to our token. Let's start by defining our module structure. Open up your favorite code editor and create a new file in the sources directory. We'll call it myfungibleasset.move. And at the top of this file, we'll define our module. The structure sets up our module and imports the necessary dependencies. We're using several modules from the Aptos framework, including object and fungible asset. These will provide us with the building blocks we need to create our token. Now let's add a structure to store the references we'll need for minting, transferring, and burning our tokens. The structure will be crucial for managing our tokens operations. The mint ref, transfer ref, and burn ref are special types provided by the Aptos framework that allow us to perform these operations securely. Next, we'll create an initialization function that sets up our token. This function does a lot of heavy lifting for us. It creates a new named object for our token, sets up the token with our chosen properties, and generates the references we'll need for minting, transferring, and burning tokens. Finally, it moves these references into the admin's account. If you're thinking, how do I know about this? Well, this is a boilerplate for all fungible assets on Aptos docs. So if you want to see all the functionality and code, you can check the documentation. Remember, what you're building here isn't just a simple example, it's a foundation for real-world application. Whether you're creating a new cryptocurrency, tokenizing real-world assets, or building a complex DeFi application, the concepts we're covering today will be invaluable. Now that we have our token structure in place, let's code the core functionalities of our fungible asset. Let's start with minting. Minting is a process of creating new tokens and adding them to the total supply. It's a powerful function, so we need to ensure only authorized users can perform it. Here's how we'll implement our mint function. Let's break this down. First, we check if the admin calling this function has the necessary capabilities. We do this by asserting that the myFungibleAsset ref exists at the admin's address. If it doesn't, we throw an error. Next, we borrow the global myFungibleAsset ref to get access to the mint ref. We use this to mint the specified amount of tokens. Finally, we deposit these newly minted tokens into the recipient's primary fungible store. This function allows us to create new tokens and immediately assign them to a recipient. It's a powerful tool, but remember, in a real-world scenario, you'd want to carefully control who has the ability to mint new tokens. Now let's move on to transferring tokens. This is probably the most commonly used function in any token system. Users need to be able to send tokens to each other easily and securely, and here's our transfer function. This function is straightforward. We first get the metadata of our token using a helper function, getMetadata. Then we check if the sender's account is frozen. If it's not frozen, we use the primary fungible store transfer function to move the tokens from the sender to the recipient. The beauty of this implementation is that it leverages Aptos's built-in transfer function, which handles all the complex logic of updating balances and ensuring the transfer is valid. This makes our code more secure and easier to maintain. Lastly, let's implement the burn function. Burning tokens permanently removes them from circulation, reducing the total supply. Here's how we'll do it. Our burn function requires both the admin and the token holder to sign off on the burning. This adds an extra layer of security. We first withdraw the tokens from the holder's account, then use the burn ref to permanently destroy these tokens. Now that we have our core functionalities in place, let's add some advanced features to make our token system more robust and flexible. First, let's implement access control. We've already touched on this in our minting and burning functions. But let's make it more explicit by adding functions to freeze and unfreeze accounts. These functions allow the admin to freeze and unfreeze accounts. A frozen account can't transfer tokens, adding an extra layer of control and security to our token system. Could be useful in cases of suspected fraud or to comply with any legal requirement. We also need a way to check if an account is frozen, so let's create a helper function for that. Now let's talk about events. In blockchain systems, events are crucial for off-chain applications to track what's happening on-chain. Aptos has a built-in event system that we can use. However, in our current implementation, we're using the primary fungible store module, which already emits events for transfers. If we needed custom events, we could define and emit them in our functions like this. This would emit a custom event every time tokens are minted, which could be picked up by off-chain application for things like notifications or analytics. By implementing these features, we've turned our simple token into a powerful, flexible system that can be used in a wide variety of applications. We have fine-grained control over who can perform critical actions. We can freeze accounts if necessary, and we are emitting events that allow off-chain systems to stay updated with on-chain activities. Now that we've built our token system with core functionalities and features, it's crucial to make sure everything works as expected. This is where testing comes in. In the Aptos ecosystem, we can write and run unit tests directly in our move module. Let's go through some key tests for our fungible asset. First, let's set up our test module. This test covers our core functionalities: minting, transferring, and burning tokens. We're creating test accounts, minting tokens to one user, transferring some to another user, and then burning a portion of those tokens. After each operation, we are asserting that the balances are what we expect. Let's also test our freezing functionality. This test checks our freezing and unfreezing functionality. We freeze an account, verify that it's frozen, attempt a transfer, which should fail, unfreeze the account, and then successfully perform a transfer. To run these tests, we can use the Aptos CLI, Aptos Move Test. This command will compile our module and run all the tests we have defined. It's a good practice to run these tests frequently as you develop your token system to catch any issues early. Now that we have tested our token system locally, it's time to deploy it to the Aptos DevNet. This will allow us to interact with our token in a more realistic environment. Here's how we can deploy our module. This command compiles our module and publishes it to the Aptos DevNet. The named address flag is used to replace the my address placeholder in our code with the actual address of our account. Once our module is deployed, we can interact with it using the Aptos CLI. So let's go through each functionality. Minting tokens. To mint new tokens, we'll use the mint function. Remember, only the admin can mint tokens. This command mints 1000 tokens and assigns them to the specified recipient address. Make sure you're using the admin account to run this command. Checking balances. To check the balance of an account, we can use the balance function. This will return the current balance of the specified account. Transferring tokens. To transfer tokens between accounts, we use the transfer function. This command transfers 500 tokens from the signer's account to the recipient address. Ensure you're using the account that owns the tokens when running this command. Burning tokens. To burn tokens, we use the burn function. Remember, this requires both admin and token holder signatures. This burns 250 tokens from the specified token holder's account. Make sure you're using the admin account to run this command. Freezing an account. To freeze an account and preventing it from transferring tokens, we use the freeze account function. This freezes the specified account. Only the admin can perform this action. Unfreezing an account. To unfreeze a previously frozen account, we use the unfreeze account function. This unfreezes the specified account. Again, only the admin can perform this action. To check if an account is currently frozen, we can use the isAccountFrozen function. This will return a boolean indicating whether the specified account is frozen. Viewing token metadata. Although we didn't implement a specific function for this, we can view the token metadata by directly querying the Aptos blockchain. This command will display the metadata of a token, including its name, symbol, and decimal place. When interacting with these functions, keep in mind the following. Always ensure you're using the correct account, admin, or user for each operation. For operations that require multiple signers like burn, you'll need to set up and use multi-agent transactions. After each operation, it's a good practice to check balances or states to confirm the operation was successful. If an operation fails, check the error message. It might indicate issues like insufficient balance, frozen accounts, or lack of permission. Remember, when building a real-world application, you'd typically create a user interface that interacts with these functions rather than using the CLI directly. However, understanding how to interact via CLI is important for testing and debugging your smart contracts. As we wrap up, let's discuss some potential extensions to our token system. While we've built a robust foundation, there are always ways to enhance and expand functionality. Allowances. We could implement an allowance system where users can approve other addresses to spend a certain amount of tokens on their behalf. This is useful for decentralized exchanges and other DeFi applications. Time locks. We could add functionality to lock tokens for a certain period, which could be useful for vesting schedules or staking mechanisms. Metadata updates. We could implement functions to update the token's metadata, like its name or symbol, which could be useful for rebranding or upgrading the token. Multi-signature operations. For enhanced security, we could require multiple signatures for critical operations like large mints or burns. Rate limiting. We could implement the rate limiting on minting or transfers to prevent certain large changes in token supply or ownership. Remember, blockchains and cryptocurrencies are constantly evolving. What we've built today is just the beginning. As you continue to develop and expand your token system, always keep security and user experience at the forefront of your design decisions. That concludes building a fungible asset on Aptos. We've covered everything from the basic structure to advanced features, testing, and deployment. I hope this has given you a solid foundation for creating your own token systems on Aptos. Remember, practice makes perfect, so don't hesitate to experiment and build upon what we've learned today. See you guys in the next project.